Chapter 18, Exception Handling and File Processing. For this chapter, we will cover the overview of exception handling, basic exception type, data, message, exception object. So the kind of the class you see is exception object. And then you can throw integer, throw a double, throw a string. They are all okay. And then after you throw it, you have to handle it. And then there's an exception handling flow. And then you may be able to rethrow it. If you don't handle it right away, you can rehandle it, and then you will process unexpected exceptions. And we are talking about some standard exception classes like emission overflow, those kind of standard classes. So these are the topics related to the exceptions. So let's look at the exceptions. So when you have a program and then you have something wrong happen, we provide a workaround so that the program won't actually get stuck. That's the exception handling, okay? So exception allows you to deal with the things that may go wrong, indicate that something unexpected had occurred or been detected, and allow program to deal with the problem in a controlled manner. So the controlled manner we talk about here is to try catch blocks. And in Python, it's try, and then what's that? Except something, right? And finally, right? So this one is try, catch, and then finally. And in Python, it's try, except, finally. Okay. And then both the mechanisms are similar. In Java, it's also try, catch, and then finally. So can be simple or complex program design technique required. Okay. Exception terminology. Exception can be object, data, a signal, and error, and you can throw an exception. So there's an exception object or value. Second, there's a throwing mechanism that send a signal that an error has occurred. Third one, you need to handle it. So three things involved in an exception. One is the object itself. The other one to throw it. Another one is the handler. Okay, so object and then occurrence to throw, and the other one is three things you need to learn about exception. When will it throw, and what will be the exception, and who will handle it? Three things. So when you throw it, you have a command called throw, T-H-R-O-W, followed by an argument. The argument can be an integer, can be a double, can be anything, and can be an object, can be a string. And try block is a block that you test something on. Catch block will be something you will catch the exception and provide a handler. So both try block and catch block, you can consider them as two different program structure or functions. So exception, the flow control. A function that throw an exception is called from within the try block. If the function throw an exception, the function terminate and the try block is immediately exited. So immediately exited. So the rest of the program will not be executed. You will jump right away. And then a catch block will continue after the exception. If the catch block is found that match the exception, then it's executed. If no, then it will not be handled and the program will be terminated. So the program will be like this. You had a try catch block. So inside the try block, if there is something wrong, inside this try block, so I'm talking about this top level, you start it from the try, so you try the code inside here. If something wrong, you actually will throw an exception and then will be catched right here. And if it happened right here, everything below will not be executed. You jump right away to here and then go here and get out. If everything is correct, nothing wrong, you will try and then finish up to here and bypass the catch part. Okay, that's basically the idea of the try catch block. And then here you have the nested try catch block. In this example, so you will try here and then enter into here. If here it actually throws some error, you will catch by this. If nothing catch, you will actually just go out of here, and then program will terminate. If it is catch, and you will run here and then get out after that. If actually nothing wrong, you go to here. Nothing wrong, you go to here, finish the whole try block, and then get out from here, and then continue to here. If something wrong here, you will still be catch over here. Okay. So that's the flow of the exception. So basically you have a try block. So you have a try block. That's a normal way of executing your program. You go into your try block. nothing wrong, you finish the try block and then continue your program. If you actually have something wrong over here, you will jump right away to catch block and finish the catch block, and then you will come back to here. Okay, you'll come back to this point. Not here, not anything there. You try to go there and try to catch block there. And if it is not catched, if an exception not catched, then the program will terminate. The program will broke because the exception is not handled. So let's look at this exception example. So here we have a function called total day. So we have integer day, integer weeks. If day less than 0 or day greater than 7, then day is a invalid days of a week. So we throw this string. So right here, actually the exception is a string. So right here, it actually is throwing a string. Okay? And here, actually, after it's thrown, where did it go? It just not handled, so everything down here will not be handled. And the object will be thrown out of the function, and then some of the higher block over there, they run this total days. Okay? Will be able to catch it. If there's a try block, and then something wrong in here, it will catch by the outside catch block. But right here, nothing handled in here, nothing. And it will not be done to continue if there is some error being thrown. Okay, so here you see right here, at a higher level, actually, you keep going to here, right? And then you're going to call this total day, and something wrong, boom, it's brought here. It actually will go to catch. And the catch is actually a string type, so that's okay. The string type is accepted, and then it been printed now. Okay, so if the error is thrown out a integer 1, then it's not catched because it was throwing the data, and that data is not catched. So data, message, and objects are 3 types of exception that can be thrown in C++. In Java, there is only objects, only exception object can be handled. Okay, but in C++, it handles data, string, and objects. Okay, so try block is entered. So the total day function is called. The first parameter is between 0 to 7. Outside it will throw a error, exception, but that exception actually is just a string. So the exception is thrown. The function try block are exited right away. Won't continue anything that over there. And catch block will scan the first one to match it. If nothing match, the program will be terminated. If some match, it will continue to do that. So this is how the exception works. The statement throw an exception, then you will be checking this catch block. Okay, and if no catch block handled it, then it will be wrong. Or the catch block may rethrow it to the upper level. That's also possible. That's called rethrowing. That's also possible. Okay. And what if no exception is thrown? Then no exception thrown in the program jump to the statement that immediately follow try catch block. So basically nothing happened, it will just jump to here. Okay, if no exception is thrown. Or it is thrown but not handled. Okay. I'm sorry. This one is not throwing the exception. If no exception thrown, it will come to here and then get out of here. Okay, so that one actually, this one actually is a successful run. So nothing wrong, it will go out and get out here. But if the exception is thrown but not handled, the program will terminate. So predefined function that has a new may throw exception. The value is thrown and does not need to be used in catch block. In this case, the no name is needed and catch parameter defined. Okay, this is fine. Let's look at it. Exception not caught. If exception is not caught, it is thrown from outside of try block.
So it has to be in the try block?
It has to be in the try block, or it will not be handled. Okay, so there is no catch block that matches the idea, and we not call, the program will terminate. So you have to, if when you try something, those code are watched. So if you will not actually tried it, it will not be caught. So right here, let's stop here, okay? Before we go into the exception type, let's look at that C++ program, okay? So right here, I have a main program. I just try a function called f of 2. right? I try f of 2. So let me go to f of 2. F function I pass the 2 over here, right? It try and it say begin try section and then odd. Okay, and then odd function actually is checking if it is odd. If it is even, it will throw 0. If it is odd, nothing happen, right? So it actually, if this number is a even number, then it's wrong. It will be thrown over here, right? It will be thrown. So if it is actually an odd function, nothing happen. And this function is throw 0, right? So here you write the throw integer. So what's that? What's the throw integer over there? You can think about this one is a outgoing parameter. Outgoing parameter, because it's throw here and you will go to here and throw out. Throw out of the odd, it will be catch over here. Okay, and then when you see something called catch ... that means catch everything. In Python, it will be except colon. Nothing there. And if you actually have the exception or something inside here, that is actually has a handler. But that here is actually that means everything. Means every error it will be catched. So default to write that is a good practice, because then the program won't be terminated. Okay, and you do nothing, that's fine. So right here, you actually say if I have an f of 2, come here, you throw 0, so 0 will be thrown, and then you will say error, C error, and after C error being printed out, you check even 0. So you go to check even 0, 0 pass over here, and if it's odd, it will throw out a message. But here, because 0 is a even number, 0 is an even number, so here it actually won't throw out anything. So the program will terminate, this f function will terminate, and then you will go to the next one. So when you go to the next one, actually, you try the f of 2, right? And then the r function actually being thrown over here, but this one f of 2 doesn't throw anything, so you will go through. This catch string message, you catch everything, will not be catch. The next one is a try 3, okay? Try 3, go here, it will go into f function, and f function pass everything. So catch block not handle, and then you go into this even with 3. Even with 3, go into even, okay, it's an R number, so it will throw message. When you throw message, what will happen? This one is a even function, and even function will throw the message not even. So the not even message has been thrown, and it will be catched by this statement. So you will say,
not even.
Main error handler message something. Okay? Is that okay? Is that okay so far? Hello? Are you okay with this so far?
Yes.
Okay, then let's go to here to see the program, how it runs. So that is the basic idea of thrown. But here, remember right here, we just talked about a string type and data type of error. We had not touched the class yet. Okay, so here let's do dir, and then we, I have compiled it before, so just run basic. Okay, so as you can see, it going to the try section, and that R number has no error, and then you go there and go to even, and even actually is no number, so it won't go into anywhere. But there, then you call f of 3, and f of 3 will cause error, and then it say not even is cut. Okay, is that okay so far? Okay, so let's go back to here. Let's go back to here. So here, actually, we finished the basic mechanism for that one, and then let's look at the basic exception type. So exception type, you can be number, integer, double, and anything. Text message is string, character string, or exception object. So everything can be thrown. Just think about it. Basically, everything can be thrown. Okay, and then the exception class, usually you like to have the exception class. Okay. And the exception class can predefine in the class, and in C++, there is a library called angle bracket exception. And usually you need to include that, and you like to use the base exception class, that would be easier to use, okay? So an exception class may have no member, used only to signal an error, and members pass error to catch block, okay? a class may have more than one exception classes. So what happened after catch block? Once an exception is thrown, the program cannot return to the throw point. It actually will depend on who handled it. The function execution throw terminate, and other calling function try block terminate, resulting to unwinding the stack. So the stack will be unwind. If object were created in the try block and a exception is thrown, they are destroyed. Okay, so actually you will rewind. Something in the try block will be rewind. So let's look at the basic one. We had to see it already. Okay. So nested try block. Nested try block actually will have multiple levels, and if a exception is thrown, it will be handled in the catch try block try catch block you have seen. Okay. Otherwise, you can actually escalate it and move up to higher level to handle. Okay, and some of level will need to handle it. Okay, and before we jump into this exception handling portion, let's look at another useful example. We are going to look at this exception type. Okay, and then not too many. Okay, not too many. Okay, then let's look at one more useful example. Okay, here I'm going to write a new program. So right here, let me actually new a project. Okay, in console, and okay, and let me go to here C double plus. Let me don't put okay, put here is okay. Chapter 18, and then here let me call the create a library called input validation. Okay, input validation is a typical try catch block example. Okay, so right here, let me remove this one, and then using namespace std. Okay, then usually I would have some integer. Say I have an integer x, right? Okay, and then I would actually say cin to my x, right? And before my cin, I would say what? I actually say cout, and then enter a number, right? Enter a number. Okay, that's the typical way we do it, right? And after that, let's do cout the number entered. Okay, and then I'm sorry, I put you the wrong way. Okay, and then I put my x, and then I put enter. Okay, so this is quite a simple program, and let's actually compile and run. Okay, run, and if I enter 3, that's fine, right? That actually is fine. So here, if I actually run and I type in 3.0, okay, because it's a floating point, but actually it got converted to a integer 3, that's fine. That's wrong. And here I don't type in number, and it actually print out enter 0. So this one actually probably handled the exception or something already, but it's not a number you want to get in, right? So here, let's assume this. Let's don't do this one actually. Let's try another way. So this one's okay, and then if I actually do this, don't use this one. Scanner, scanf, and address of x, right? So that if I try this way and try this one, right? Let's see, okay. Right here, compile and run, and I type in garbages. Oh, okay, something like this, okay. Anyway, I don't know how to create an error case, but in fact, that's not a number I want to have, right? So I can actually do this, okay? I can actually do this. I can do try block, right? If I enter a number, oh, this one actually it can be anything. It can be a string, right? Let me see. Let me see right here. Let me see. So if I do this, don't do this one, okay? If I actually C in to x, right, and integer y equals x. Let me see if this work, okay? So here let me do dot dot dot, right? And here let me actually, if I actually click this one, and then I here C out. Okay. Let me see, okay, if this one actually worked. Okay, and I try to create trouble. Still enter 0. Let me see. Something wrong. Something wrong. It doesn't throw an error. CL. It is supposed to. Maybe this C in CL already handle the error. Let's see. How can I actually get a number for integer? And I use a scanf, it still actually pass. Okay, let's do this. Okay, let's do this. Let's call a input function. Let me try this one. Okay, so let me try say void get input, right? So here actually let me throw integer, right? I throw an integer, that's an outgoing integer, right? And then I have this one. So I have x over there, and I cut the whole thing over here, right? I cut the whole thing over here, right? I cut the whole thing over here. And then let me see here. And right here, actually I have x equals get input. Okay, something like this. And right here, let me see here, I return integer instead of not entering anything. It's just supposed to have error if actually it's not the right type. Okay, if it's not the right type. I'm not sure. So this one x is not declared. So here let me declare it's an integer. I'm not sure why cin can actually provide to data which is actually not integer. I'm not sure. Okay, I'm not sure why it actually won't create trouble. Okay, so here let me try type something. I'm not sure. Okay, I'm not sure why. Let me try to see if there is something like C double plus wrong input format. Okay, so wrong input format in C double plus. I have this one. Enter a number and then C in the failed equals C condition. Okay, so it actually need to do this. If it is an integer, you try to enter an integer. And then C in the clear. Okay, so you actually will get a C in condition. If it fail, so fail will be true if it actually fail, right? It actually fail. So let's copy this guy over. So this one ignore integer maximum. So that's actually get this guy over. That's this whole thing over. I think that's what it should be handled in C-in environment. I'm not sure because I write more in the kind of code in Java. It's a little bit different, so I'm not familiar with this C-in. So here we have this C-in equals to fail, right? Before that, it actually has this one enter integer c into n, right? That actually is the same as ours. So this one is okay. Just cut this guy out. Okay. Okay, just cut this guy out. Okay. So we had this and then we clear it. Okay. So right here, let's do this. Let's get rid of this one. Okay, we don't die this one. So here, condition will be true if it is actually failed. So here, let's do this. If condition, right, throw 1. Okay, and then this is a clear. Whatever actually won't be done, right? So this get input is not needed. Okay. Okay, so this one actually won't be done if it actually goes to there. Okay, so let's do this one. Condition is what? Condition was not declared in this scope. What's that?
On was no type.
Oh, it's a Boolean type. Okay, it's a Boolean type. So let's see. So we need to actually is bool is used here. So we can directly call it bool. Okay, no need to put anything anywhere else. So let's try this one. Okay. It actually, oh, okay. So actually there is an error, but the one that number enter is the end of the program. Okay, you see that? So right here actually is throw 1 and it can catch by here, right? So let's assume that we do nothing. Okay, no, let's do this. Let's not do this. Here to enter again, right? Here let's do enter again. Right, so right here, let's do this. Here I have my bool down equals false, right? And I would do this. I tried this try block many times. I tried this block many times. Okay, so actually I can have this C in and clear before my catch block, before my throw block. Okay. And if I actually not throwing any error, if say I don't throw any error, that means my input is successful. So I do my down equals true. Okay, otherwise it will enter into this try again, and then here I will do the while loop, the end of the while loop. Okay, this is try catch block, and here I will say while not done. So I continue to read something in, right? If the format is correct as an integer, what will it do? If it's a correct integer, the condition fail will not have no fail, and it will say done. And then once it's done, it go out of here, and then while done get out, you will get out and get a number, right? And if it actually raises an exception, done will not be true, and then you will go to this catch block. It will have exception, jump to catch block right away, and say enter again, right? And then you go back to the try block, and then enter a number, and then keep reading that until a successful one is done. So this one is an input validation. Simple input validation loop. So here, let me try this, try this, try this, try 0, it jump out, right? Wrong again. Here I do 89, it get out, right? Try again. I have this one. Okay. Oh, this goes through.
Because it's a number, and then it takes the number, and not the other stuff.
It doesn't take the other stuff. That's the cins function, right? So actually, cin is not really secure. Cin is not stupid. Anyway, that is a demonstration of input validation. Okay, that is the function of input validation. That's the function of input validation. Let's continue. So we finished that the use of the exception types, right? Then we actually now we'll go into the exception type. Okay, exception type we have this, exception class, then package block. Okay, exception indicate problem occur in the problem. So not common, and exception is the program that usually work, and the generally is to resolve the exception, and program may be able to continue. Okay, or control termination. Okay, either one. You can continue or like my case, my input error case. If I enter something wrong, I will let it continue to enter until a good one is happen. But some program may just want to have a control termination. Okay. So this one's okay. I don't want to waste time on these different things. Okay, and then try catch block is fine. Throw point, there's a throw point. This is fine. I think it's okay. And you can also ignore the exception. So basically, I think the indicator in your function say no exception is no exception. Don't allow exception. Okay. And this one we do have a throw exception. That means that be careful. There's some output exception will be thrown out, right? So this is an outgoing exception, and the one you see that there is no exception, right? That one actually is saying that function won't create exception, right? So that's that. So this bar is okay. I think this function set error status, set jump, long jump, these are okay. Division by 0 is okay. And let's look at this are okay. We can look at this. Okay, let's look at this one called custom exception. Custom exception is the next one we would like to have. It's using the block class to build exception. So let's look at the custom exception function. So here I have include an exception, right? And then I create a class called divide by 0 exception, and it actually inherited the public runtime error, right? So this one actually use the runtime error constructor to enter a string called attempt division by 0. So divide by 0 exception actually has a message of attempt division by 0. Is that okay? Is that okay?
Yes.
And it's a standard runtime error, okay? Now here I have a main program. I have integer 1, integer 2, right? And then enter 2 numbers. And then I get, so here I get a quotient. And then this quotient function, I actually divide my numerator with denominator. So if the denominator is 0, I will throw this division by 0 exception. So it actually will not print out a quotient. You jump to here. Okay, so it will catch division by 0 exception and this division by 0 exception. That actually is another exception, and then you will actually print out that what actually will print out a message attempt division by 0. So this that what actually is to get a message. This is that what.
Yeah, I see.
Okay, this is that what. Okay, let's run this one. Okay, this one is called custom exception. That's the one you actually will need, right? Well, in your program, you will need this one, right? So yes. Let's go up a stair, dir, and then cd custom exception, dir, and then we just run custom. Okay, so enter 2 integer. You want me to enter 2 integers, so basically it should be like 10 and 0, right? End of file is Control G, so let's do Control E. Okay, and it said that when I say Control E, actually, it said that it's attempt to divide by 0. That's the what will print now. Okay, so that what actually is what? Get message. Is that okay? The that what is actually doing get message, and what message you will enter when you actually have your what? Let me see. This one. No, not this one. This one. When you have a runtime error is one kind of the exception, right? Under exception. Exception is the top level exception. So runtime error is one exception, and each exception you can put in a something called this a message, and then you just say that what you will get your message, the one you enter over here. So this one is calling the definition for the constructor for division by zero exception, and it will run the parents constructor once. Okay, and then send this message back into the body of the division by zero exception. Okay, so here actually, as you say, oh, I'm sorry. This one is what? It's actually is a S sign. This one is an alias. Do you see that? This one is the alias of division by zero. So the type is capital divide by zero type. Okay, so when you throw out, it actually is a object, right? Okay. It's an object. So here actually is using a variable, and this one is the alias of that object. Oh. So in your C++, in your Java, here is a throw new division by zero exception, right? But this is actually a what? This actually is C++, so there is no new. This one is actually an object. New, you create a what? A pointer. I don't like the pointer. I want the object, right? I want the reference. So the reference actually need to match with a reference. This is a reference, and this reference type is divide by zero exception type reference alias. And that object I take that one. So this alias somehow is used as a reference variable representing a object. So when you store this, it will be catched by a alias like this. Somehow this also answers your question of when do you need this one. Okay, they two occursion. When you need to update some variable, that one need to return a alias type. The other one is that when you need to use that object instead of pointer to actually get the object's method, instead of using pointer, you need to do dash arrow. So this one, in that case, you need to have a reference that what to get the member function. Is that okay? So that is what. And then next one is rethrowing an exception. Sometimes your catch block doesn't handle the exception right away. And in that case, you need to resolve the exception. So let's look at the rethrow. Okay, let's look at the rethrow. The rethrow of the exception is right here. So rethrow function is right here. We have main program, right? And we actually see our print out this and then throw exception. So when you throw exception, it actually is a function over here, right? You call this block, you come to here, try block, and then you do something, and then you throw a exception. So exception got thrown out. When you throw out the exception, that exception being cut by this exception cut exception. Okay. So this one is the areas to accept that exception object as a reference to the exception object here. Okay, go to 3. So go to 3 is print, but you did not handle it, so you thrown again. That one was thrown what? Thrown this catch exception to upper level again. So this one thrown, once this is thrown, it get out of this through exception function, it come back to 1 and it will be caught at the 4 location right here. So you come to here to handle that exception handle in main. So this one is handled, this case in here it not handled, but it actually propagate. We thrown it to an upper level. Is that okay?
Yeah.
So basically your program execution is like, you come to here, call this function, come to this function, try and destroy exception. So exception come to here, catch. And catch, even though it's catch, but right here, you will, okay, I will restore the exception. So you get out of here, come to higher level, and come back to here. There is an exception, go here to be catch, and it is handled. Once it is handled, you finish this part, right? You finish this part, and then you will continue to 6.
Okay.
Okay? So that's the flow it actually will go. And then here it has different things. Okay, you can run this program to find out. Okay, anyway, I don't waste time. So exception, you can actually throw multiple exception. Exception A, exception B, exception C. You can in one function. That time we just saw one exception, but in fact you can throw multiple exceptions. can only throw exception A, B, C. Okay, whatever. Process unexpected exception. So basically, if you want to process unexpected exception, you can actually usually just use this one called function unexpected. Okay, and then call by default terminate by default. Okay, if you don't process anything, the program will terminate. Otherwise, you can set the terminate to see what function termination call will do. Okay, by default, you will call abort. Okay, but that is actually not important. Stack will be unwind. Whatever process, if it's actually been create the exception, the stack or something, it will be rewind. Okay, you will rewind properly. So that portion actually, I mean, this one's okay. This one okay. Exception class. Let's look at this exception class. There's a constructor, destructor, and exception handling. So you don't try to use new. Try to use new. You may not be able to create memory. That's an exception. Okay, and then you can throw an exception right away and use the alias to catch it. Okay, use the area to catch it. New operator. The new operator may fail, and you will throw a bait allocation exception. This is different. Okay, this is when you actually has the creation error. So basically, you have a pointer to an array, and then you try to create a super big array for this I. So you will actually fail. You will actually fail. When you fail, actually it will create trouble, and then it will throw out a bad memory allocation error. So you will actually terminate and throw out a bad memory allocation error, and it is not handled. Right here, it's not handled. So you will show up in your top level execution because it's not show. It's actually not continue to finish the program. Okay, so that one. Let me see. Memory operation. So this one actually, I think is good enough for you to continue, right? So the next thing is like standard library. There's a base case, so called exception, and there's also two other derived classes: runtime error and logic error. So three different error: compilation error.
The one right now, the future ones.
Yeah.
Is it a runtime error?
It can be a runtime error or logic error or the type of whatever error, but runtime error also inherit exception. Logic error also inherit the exception. So it actually is the very base class.
Mm-hmm.
Okay, so your exception actually create big allocation, logic error, runtime error, backcast. And here are several types of error. Maybe you have overflow error, dense error, out of range error. These are the typical error name. When you actually include the exception, standard exceptions. Is that okay? These are typical standard.
So out of bounds would be logic error then.
It'll be this one, out of range error.
Yeah, so it would be logic.
Yeah, it's a logic type error. Okay, so these are the exception library you need to actually study here. Okay.
I have a question. So this constant and no except.
Constant is the output cannot be changed. This whole function cannot update some of your data. No exception.
No except means no throwing.
No breaking of the function. You cannot jump to the upper level to handle the exception.
So over here, how do I throw the exception over here?
I don't know. Index out of bound has nothing to do with this.
Fine.
It has nothing to do with fine.
No, I mean like.
So here you define a out of bound exception, right?
Yeah.
And then in certain cases, you need to create an object based on this out of. You need to include this function .hpp into your main program, right?
So I have to write my own out of bounds.
No, class? Here you should actually. This one you should include exception. This one you include, yeah, right there, include exception. Right?
Like that.
Yeah. And then this one at the end, column. At the end of the out of bound exception, column, public, what? The kind of error I just showed you.
Logic.
Logic, all this, what, out of bounds, you find appropriate error for it. You know what I'm saying? Then you just need to build a constructor and then use that parent class constructor to put in the message. That's good enough. Remember that one? So I should send you my chapter 18 code and chapter 18. I should send you my chapter 18 code and also chapter 18 slices. Is that okay?
Like this?
Yeah. Yeah, this one's out of range. Yeah. So yeah, that's.
So this is.
This is you define it, but when you use it, go lower this example. Go lower this example.
Okay.
Yeah, this one. Yeah. So standard except, not exception. Standard except is also standard except is the out of range exception.
So standard except is when I use it in my code, right?
Yeah. Not exception. Not exception.
So this is the out of range class right here?
That's the definition of out of range class. Nothing to do with you.
So my definition would be public. Would I use out of range or would I use logic?
Out of range.
Like that?
Like that, and then put something in there. What's the constructor need to be? Or it doesn't take any message or something?
Like this?
Yeah.
So I just copy this?
No, that one is actually that is not your example. That is actually what? That is actually class out of range. You should do okay. You can do that. The out of range two type. One is string alias type. One is a character. So one accept the C string. One accept the C double plus string. Is that okay?
Wait, so I can just, over here, I can just write if something throw?
Yeah.
That's it?
Yeah.
And then this one catches and it prints out the error?
No, not here. Not here. This is an object only.
Yeah, but I'm telling this place catches the error, right?
No, not here. This one only define the exception.
So what catches the error then?
Please go back to your C reference guide. Go to the USC reference guide. When you write in the main program, go down the example. When you go down, when you try to create and not in the string but CPP, but in the main function, you create a string and you try out of bound operation.
Oh, so this thing catches.
Yeah, this one will catch it. Yeah, that one will catch.
Okay.
You know what I'm saying?
Okay. Okay, I think I know how to do it then.
Yeah, so then you
if I just copy this into my this part,
or you can actually
and then
it won't be far away if you actually still can get it work. I think.
And then
I think you're at the point that Stack Overflow can help you now.
Okay, I'll finish this part and this part.
Yeah.
And then I can start testing. And
and then test one by one. Yeah.
Okay.
But make sure you don't have compilation error in these different functions.
Okay.
Okay. And then you start testing one by one. Okay.
Okay. Okay. Bye.
Okay. Good luck then.
Yeah.
Bye now.